Hello, we are Catalina and Eduardo, and we are presenting for a project, the housing affordability in the state of Georgia.
So the purpose of our project was to better understand the home affordability and demographic patterns in Georgia by combining different data sets from census, Zillow, World Population Reviews, and a United States Census API. The main goal was to figure out what drives housing prices and which counties are the most or least cheap, as well as what geographic or demographic factors influence these trends. This would allow us to provide a more complete picture of Georgia's housing markets, including the relationship to income, utilities, family size, and demographic trends. So why did we choose this topic? We chose it because housing affordability is a main issue everywhere, but we wanted to focus on Georgia specifically. We chose the following data sets, so like the PUMS, because it contained household level data such as income, home value, utilities, rooms, and age of the property. The Zillow dataset, because it tracked county level home prices and changes across time. The World Population Review, because it contained county populations, density, and growth. And the 5-year census API, because it contained median household income by county.
Now, before the project, before analyzing the data, we expected to find that higher incomes mean higher home values because people with more money can afford bigger houses. Newer homes to cost more, the ones that were most recently built to cost more money. Then the rural counties to be more affordable than the metro areas. The suburbs to be a balance between the two because they have larger family sizes. And finally, that population growth should be correlated with rising home prices because if more people are moving into the county, home prices should obviously rise. And you'll see later, but most of these expectations were actually confirmed in our data analysis.
So for our first data set, we have the Zillow process data. And what we wanted to do was take from this Zillow the columns that had the elements that we wanted to focus on, such as the region, the state, the home value 5 years ago, the growth rate, and the size. So we created filters that would eventually capture the data that we wanted to focus on and then print the change that the properties had between 1 year and 5 years, and also the percentage.
Then we also did with the county data HTML, we brought out some values like the population, the density per square mile, its growth, and the area of the county so that we could track these demographic statistics. And as you can see here in the code, we filtered the values that we didn't want, and we used some regex to change the value so that they would be meaningful.
Then we use the 5-year census API to also we cleaned it because it contained some values that we didn't want, and we wanted to obviously find out more about the population and the median household income. So we found the median values, and eventually returned, obviously by the property, what were like the median household for that, the median price for that property in specific.
Finally, our biggest dataset was a PUMS CSV file that contained over 52,000 properties in the state of Georgia, and it contained over 200 columns of data that had a lot of information in it, but it also had a lot of missing information. So we had to address nans and some values that weren't representative of the reality. So, and we also selected the columns that we actually were meaningful for our project because it had more than 200, and we only needed a decent few. And then we cleaned the data set and we had almost 10,000 properties left that had the meaningful data that we wanted, which was still a pretty good data set.
Now, for our first insight, we used a linear regression model to predict the home value of the property. So here we wanted to know what were the factors that most have an impact on the property value. And this can be the number of bedrooms, the property age, and the income of the family. So we used linear regression to then help us find out like what the impact that each of these factors have on the home value.
Then for second insight, which was the second using sklearn, but it can be linear regression. So we used another of the topics that Christine teach in class, which was KNN, K nearest neighbor. And we used the model to estimate the affordability based on the 15 most similar households to the one we were trying to predict the value of. And we created the affordability ratio, which was home value over income, to measure how much of their financial budget families would need to allocate to buying the house to test the affordability in each of these counties. And we had some interesting findings that we expected. Household income plays a major role in affordability. Obviously, families with more money can afford the better houses. Property size and bedrooms and number of rooms also matter. And utility costs matter, but much less. As you can see in the table, they have little to none effect on the affordability of the house using our model.
Now, for the third insight, we merged the Zillow home value data with the country level census income to calculate the affordability ratio. So dividing the median home price with the median income for every county. And then we sorted the counties by the ratio to create a ranking that would give us like to help people know what are the counties that are the most affordable versus the ones that are like the least affordable.
Then for Insight Fort, we wanted to look with trends for the price change for the last few years and also related to how many people were moving into the county. So here we have a table of the most significant ones that have the biggest price changes and the biggest amount of people moving in, or negative price changes, even counties that got cheaper. And our findings were that northern counties are growing the fastest, and as we expected, that rural areas show more stable but slower growth, and also interestingly, some metro counties saw price drop recently, like Gwinnett, Fulton, or Cobb.
For our fifth and final insight, we compared four area types, big cities, suburbs, etc., small cities, rural areas, by calculating the years of income, such as like the home price divided by the income. So this metric was used to assign a affordability label to each community type. So as you can see on the table, the big city, we found the average income, the average home price, and the average family size, the home age, and we assigned an affordability ratio, which in this case was expensive. And we did that for the four different areas.
Now here we have a first visualization. We chose the linear regression model. As you can see in the graph, the model was pretty accurate. We tested bedrooms, rooms, and property age to see how big of an impact each had. And we used Plotly to plot this graph of the accuracy of our model with the actual home values and the predicted ones. And they were, most of them, except a few outliers, most of them were pretty close to the prediction. So it was a pretty accurate model.
For our second visualization, we did the KNN model prediction accuracy. So as the previous visualization, we wanted to know how accurate our prediction was to the actual data. And as our previous, it's pretty accurate. And we also wanted to calculate the housing affordability distribution, as you can see in the graph below, by the number of households and with the affordability ratio that I mentioned of the home value with the income.
As you can see, we use graphs for both of our sklearn models because we thought it was the toughest part of the project. So we wanted to showcase our results we were very proud of. Finally, our third visualization is a map of the affordability in Georgia. This one was a lot of fun to make because we can see clearly on the map which counties are the most affordable according to our previous metrics. And we found that, as you could expect, the most of the counties closer to Atlanta and to metro areas are more expensive. And around the least populated areas, there are very much more affordable counties. So it was a very interesting graph to make.
So what did we learn? This project taught us to extract and merge numerous real world data sets and normalize them using sophisticated cleaning techniques, which was very complicated because most of these data sets contained thousands of information that we had to filter out. We also learned how to scrape data across the APIs, JSONs using Beautiful Soup and Plotly. We also use much advanced machine learning algorithms such as the KNN and linear regression.
Our conclusion is that our research demonstrated accuracy, the housing affordability. It's influenced by a lot of factors, not just income. And as we said before, property size, property age, expenses are something that changes the prices of the housing. So we were happy with our results. They match our prediction at the beginning, and our affordability ratio highlighted geographic differences.
Thank you.